The format of the read file names start with an alphanumeric code specifying which sample it came from. So here, for example, this R6 is a code specifying a certain sample. And then the alphanumeric code is followed by sub, and we inserted that in there just to denote that we subsampled these files from their larger files in order to run the tutorial. And then we have either an R1 or an R2, where R1 specifies the forward read and R2 specifies the reverse read for the sample R6. And here we have .fq files, which are files with both genetic sequences and quality score information, and then we have .fa files here, which are simply just sequences with no quality score information. For some basic information about these formats, please visit our fastq format page link below. So for our first step in this part, we need to merge the forward and reverse reads for each sample. So we need to merge this R1 and R2 into a single sequence of the sample R6. So please see our link below for a visual on the merging process. For this particular sequencing run, we conducted 2x300 paired end Illumina sequencing over the V4 region of the 16S rRNA. And the V4 region is roughly 300 base pairs. So given that we ran 2x300 paired end sequencing over a 300 base pair region, we have virtually full overlap. And please see figure 1 below for a visual of what that looks like. Now the benefit of full overlap as compared to sequencing another longer region of DNA that has less overlap is that we have improved base calling accuracy with full overlap. And here we are going to use the program usearch over vsearch in this case, because usearch will trim any part of our forward or reverse reads that run past where they should. And you can see a visualization of what we mean at this link below. So we're going to use usearch here, and we are going to specify this subprogram inside of usearch called fastq merge pairs. And we'll use this to merge our reads. And typically, you work on individual samples. So for example, you would type that in, and then you would specify a sample, like so, and then you would specify your output file, which we are just going to call b1 submerge.fq, and we can name that whatever we want. So notice that we don't have to specify the b1 sub r2.fq file, because what usearch does is it searches for the b1 substring inside the same folder, and then it matches this file to its corresponding r2.fq file, which is really nice. So as you can see, we have multiple files we have to do this with, which is typically the case. So instead of repetitively entering this command a bunch of different times, we're going to use a little bash shortcut that with one line of command we can work on all the files at once. So we're going to use a little character that's a wildcard, and it's going to be this star character. So if you're unfamiliar with bash wildcards, please shoot over to our wildcard section of the bash basics page where you have some time to learn about them. For now, all you need to know is that this star represents matching anything any number of times. So it can match a letter like this R here, it can match a number like this 6, it can match an underscore, it can match anything that you need in the bash when you're doing bash language, which is really, really useful. And so we will use it to match everything all at once, and I'll show you what I mean in a second. Okay, so let's outline the steps that we will be undertaking in order to merge all the samples appropriately. And so first we will merge the paired reads for each sample into a single sequence. And then usearch will rename the merged sequences so that each sequence header now specifies which sample it originated from, which is useful because we're combining all the sequences into one file. And so after this renaming, all of the merged sequences that we just created will be input into a file that where we will choose the name of. And then usearch will calculate new quality scores for each position or each base of the merged sequence. And we have a link below to detail how that's done. So here's what the command looks like. We have usearch just as before, and we have fastq merge pairs. And here's where we denote that star and underscore r1.fq. So notice before we just had a single file name underscore r1.fq. With the wildcard, we can say grab all of the files with r1.fq. And in doing that, usearch will also match all of the files, the corresponding files of all of these R1s with their corresponding R2.fq files. So then we need to specify our single output file, and you can name this however you want. We're going to name it all samples merge.fq. And then we have a relabel with an @ symbol, which I'll explain in a second. So let's go over this line to make sure we know what it's doing. So we call the program and its subprogram here, and then we use the star to match everything that has an r1.fq, and then usearch will find their corresponding r2.fq files. We specify the fastq argument to denote our output file here. And then for the last part, we call on the relabel argument and then put an @ symbol, and that tells the program to rename the merged sequences based off which samples they came from. So let us run the command, and this is the output usearch prints to the screen as it's running, and there we go, it's done, and it prints some summary statistics for us, which is needed in order to have some idea of what's going on with our sequences as we move along with the analysis. So here we can see almost 90% of the sequences were successfully merged, which is pretty good. And reasons for failed merge attempts are due to default filtering criteria inherent to usearch. And you can look at those default settings at the link below. But for now, we successfully merged our reads, and most of them were successful. And if you do an ls and you look inside your folder, now we can see all samples merge.fq. If you do ls-l, all samples merge.fq, you can get a file size. And that file size, because it's integrating all of the different sequence from all the different samples, that file size should indeed be a good amount bigger than these .fq file sizes, and indeed it is. As you can see right here, it's significantly bigger than a lot of these files.